Hi, my name is Eric Notless, and I'm an MD PhD student at the University of Michigan. This is a brief intro to our paper on updating clinical risk stratification models using rank-based compatibility. Docs and models function as teams. Docs may have a sense for which patients are at risk. Models may also assess those patients. Together, the doc model team may assess patients better than either would alone. So if you're a doc using a model that did a pretty good job of ranking patients, you might be pretty happy, and your team performance would also be pretty good. What happens if you get an updated model? Well, if the stratification method changes, you might not expect that, so your team performance might suffer. Joint human model team performance has been shown to degrade in the context of model updates. Bonsall et al. Introduced a concept of compatibility to measure the change in behavior induced by a new model. Compatibility is a measure that quantifies how much an updated model continues to produce correct behavior exhibited by an original model. If you want good team performance, you want to select updated models with high compatibility. Bonsall's compatibility measure is useful for assessing classification models. However, there are some problems when using it in ML for healthcare. It depends on an equality comparison between the models' labels, thus it's not well suited for use with risk stratification models. To use this measure for risk stratification models, we need to employ decision thresholds. One issue is that there might be several thresholds in use. Additionally, you might just forgo thresholds entirely. You might use rankings to select the top X patients based on resources available. In this case, you're just interested in ordering patients. Stratification is generally what we're trying to maximize in ML for healthcare. Performance is generally measured using the AUROC measure, and the existing compatibility measure has no direct relationship to AUROC. Thus, you can't directly assess any trade-offs between compatibility and performance. Our work addresses these gaps. We define a new rank-based compatibility measure, CR, we characterize CR and its relationship to AUROC, and we introduce methods to generate updated models with high levels of CR. CR measures the chance that updated models correctly ranks a patient pair given that the original model correctly ranked that patient pair. CR takes an original and updated model and compares their risk estimate rankings. In blue, we assess the original model. In yellow, we assess the updated model. We count the number of times that both models rank patients correctly and normalize by the number of times the original model ranked correctly. This yields a value between 0 and 1 and can be thought of as the probability that the updated model ranks a patient pair correctly given that the original model correctly ranked that pair. We also introduced rank-based incompatibility loss and a differentiable approximation. The minimization of these leads to higher levels of compatibility. To recap, we introduce and study a new rank-based compatibility measure to assess risk stratification model updates and a loss function to generate models with high levels of compatibility. We show their relationship with AUROC and empirically evaluate updates using a mimic-based mortality risk stratification task. Please follow the QR code for more details. We look forward to discussing model update compatibility with you at the 2023 Machine Learning for Healthcare Conference.